Hello students, this is lecture number 7 of this nuclear physics course, and in this lecture we are going to discuss about the statistical behavior of nuclear particles. Students, the nuclear particles, protons and neutrons, they are indistinguishable particles. Also, if we discuss electrons, they are also indistinguishable particles. And from the knowledge of the statistical physics, we know that the statistical behavior of indistinguishable particles, it can be explained only quantum mechanically. Okay, so we have the two quantum statistics here. First one is the Bose-Einstein and the second one is the Fermi-Dirac statistics. The Maxwell-Boltzmann statistics, this is usually called classical stat, and it is applicable for distinguishable particles, or you can say classical particles. So we are going to discuss in detail about these two states, Bose-Einstein stat and the Fermi-Dirac stat. So first we will discuss the Fermi-Dirac statistics. Students, this Fermi-Dirac statistics is applicable only to the particles having half integral spin, that is 1 by 2. It may be 3 by 2, 5 by 2 and so on. But remember, it is applicable only to the particles having half integral spin. And the particles which obey this Fermi-Dirac stat, these are called fermions. Fermions also have other properties, or you can say fermions are the particles which obey Fermi-Dirac stat, and so also we can say fermions are the particles which have half integral spin. Next, please come to the next page. Students, fermions are the particles which obey Pauli exclusion principle. The basic definition of fermions is the particles that obey Fermi-Dirac stat, but they have the properties that they have half integral spin. They obey Pauli's exclusion principle. You must know about the Pauli exclusion principle. And the nuclei with odd mass number A, जिस न्यूक्लियस का मास नंबर odd है, it means if we have odd A, it means उसका जो spin होगा, it have half integral spin. Such nuclei have half integral spin. So nuclei with odd A obey Fermi-Dirac stat because such nuclei have half integral spin. Okay, now let's discuss something about the wave function. Students, you know very well from the de Broglie hypothesis, that it says that if a wave has a particle nature, then particle also have material particle also have a wave nature. And if a particle has a wave nature, it is described by a wave function. And wave function further depends on the space plus spin coordinates. So what we have discussed, if we have a system consist of first see here, a particle has a wave associated with it, which is described by a wave function. And if we have a system consist of a large number of particles, then such systems are represented by a wave function, and that wave function would be superposition of the individual wave function of all particles of the system. तो आपका सिस्टम का अगर वेव फंक्शन निकल जाता है आफ्टर सुपरपोजिशन of the wave functions of all the particles of the system, then wave function further depends on the space and the spin coordinates. Okay, both space and spin coordinates. So for the system that obey Fermi-Dirac stat, उसका wave function कैसा होगा? That wave function would be antisymmetric. The corresponding wave function would be antisymmetric. For the system that obey Fermi-Dirac stat, the corresponding wave function is antisymmetric. Now let's see here what is the meaning of antisymmetric. If we have n particles having coordinates x1, x2, xn, it represents general coordinates. It represents general coordinates. General coordinates, I mean to see here that space plus spin coordinates. Space plus spin coordinates. Uh, let's write here xn. So if we interchange the coordinates of any two particle, it is not necessary that they should be particle 1 and 2. If we interchange the coordinates, both space plus spin coordinates of two particles, then the wave function would be like this. It means its sign would change. Sign of the wave function will change on interchanging of coordinates of two particles. So we have written here, if we interchange the coordinates, both the space and spin of any pair of identical fermions, then the sign of the wave function will change. This is the property of the wave function describing fermions which obey Fermi-Dirac state. ठीक है जी. Now let's come on to the Bose-Einstein statistics. Bose-Einstein statistics is applicable to the particles with zero or integral spin such as photons, or we have nuclei having even mass number. If a nucleus has a even mass number, then it would have integral, then it would also have zero or integral spin, and such nuclei also obey Bose-Einstein statistics. And the particles which obey Bose-Einstein statistics are called bosons. These are called bosons. So the wave function for such a system for bosons is symmetric. And what do you mean by a symmetric wave function? Symmetric wave function means if we interchange the coordinates of two particles of the system, then the sign of the wave function remains unchanged. Sign पे कोई फर्क नहीं पड़ेगा. Let's come on to the next page. Now we will understand this symmetric or antisymmetric wave function by another perspective. Okay, since we know, students, we know that nuclear particles, protons and neutrons are identical, so the probability distribution that is represented by psi square, you must know that probability is represented by psi square from the knowledge of quantum mechanics, and it remains unchanged by the exchange of particles because particles are identical. There will be no change in the probability distribution by the interchange of the particles. So psi square, whether it is x1 x2 or x2 x1, even after interchange the probability would remain same. Probability of finding the particle, it would remain same. But if we remove the square, then we can have x1 x2 is plus and minus. This sign, whether we should take plus or minus, and then it is found that for fermions we have negative sign, that is psi x1 x2, and if we interchange the coordinates, that is x2 x1, then we will have change of the sign for the fermions, and the corresponding wave function is antisymmetric. Fermions are also so we have written fermions are described by antisymmetric wave function. For the bosons we would have positive sign. For the bosons we would have positive sign, that on interchange of the coordinates, there is no change in the sign of the wave function. Such function is called symmetric wave function, and it is used to describe the bosons. Bosons are the particles which obey Bose-Einstein state. Okay, let's come on to the next page. Now we will discuss about the parity. Students, parity, it is a property of a wave function. A wave function that describes a system, and it has no classical analog. We don't discuss about parity in the classical physics. So the parity of a nucleus describes the behavior of its wave function. Parity describes the behavior of the wave function of the nucleus, or you can say any system, as a result of inversion of space coordinates. So let's try to understand it. ये आपका अगर 2 डायमेंशनल स्पेस कंसीडर कर लेते हैं और यहाँ पे आपके फंक्शन की पर्टिकुलर वैल्यू है, फॉर एग्जांपल साई, एंड दिस इज x, y. तो अगर हम कोऑर्डिनेट्स हम यहाँ पे आ जाते हैं और इस पॉइंट का जो कोऑर्डिनेट है वो -x और -y है, तो आपके फंक्शन की वैल्यू -x -y भी हो सकती है और यहाँ पे x, y भी हो सकती है, डिपेंड्स ऑन पैरिटी. लेट्स अंडरस्टैंड दिस. The motion of the nucleus is said to have even parity. Even parity कब होगा? जब inversion of space coordinates, due to inversion of the space coordinates, special part of the wave function remains unchanged. जो ये क्या है? space coordinates. तो special part जो है, जो space part है, special part of the wave function remains unchanged. आपने mirror image के point पे पहुंच गए हैं. आप ये मान के चले, ये आपका कोऑर्डिनेट है. दोबारा से एक्सप्लेन करते हैं. यहाँ पे ये आपका हम 2 डायमेंशन में एक बार समझने की कोशिश करेंगे. दिस इज अ पॉइंट. इफ आई से इस कोऑर्डिनेट्स आर 3,4, तो हमें इसकी यहाँ पे ऐसा मान के चलें कि हमने यहाँ पे एक मिरर लगा दिया और मिरर जस्ट इसकी इमेज कहाँ बनेगी? यहाँ पे. ठीक है बच्चों. और इस पॉइंट के कोऑर्डिनेट कितने होंगे? -3,4. हम यहाँ पे इस पॉइंट पे साई को इवेलुएट करेंगे कि वेव फंक्शन यहाँ पे कितना है और यहाँ पे कितना है. अगर दोनों जगह पे इफ़ वी हैव same psi at both places, that is at xyz and -xyz, then it is said to have even parity. And if the sign of the wave function changes, then it will have odd parity. That is, even parity represented by the plus sign and odd parity is represented by minus sign. Let's come on to the next page. So parity is also defined by an operator. This is called parity operator. You must have come across the operators in your quantum mechanics course. Parity operator. In terms of operator, we can understand that if we apply the operator P on a wave function, then we may have plus or minus psi x, y, z. Okay, parity operation means it reverses the coordinates, space coordinates -x, -y, -z. तो पैरिटी ऑपरेशन लगाने से क्या हुआ? आपका जो वेव फंक्शन एक्स वाई जेड पे था वो आपका -x, -y, -z पे पहुंच गया है. अब -x, y, z पे वैल्यू इवेलुएट करते हैं. अगर उसकी वैल्यू सेम है तो इवन पैरिटी है, और अगर साइन चेंज हो जाता है देन इट वुड हैव ओड पैरिटी. सो द पैरिटी ऑफ द एंटायर सिस्टम. अगर आपके पास दो पार्टिकल्स हैं और उनकी एक सिस्टम के अंदर, तो उनकी पैरिटी कितनी होगी? उन दोनों की पैरिटी का मल्टीप्लिकेशन. मान लीजिए एक का पैरिटी इवन है, दूसरे की ओड है. इट मीन्स आपका सिस्टम की पैरिटी ओड है. Positive into negative, it will also give negative. So the parity of the entire system is the product of the parities. It is, you have to remember, it is not addition, it is product. It is product of the parities. Product of the parities of individual particles. Nuclear states are characterized by a definite value of parity which can be different for different states. We will discuss this with an example also. In case of a hydrogen-like atom, if we discuss about a hydrogen-like atom means जिस एटम में एक ही इलेक्ट्रॉन होता है. Then the parity is related to the orbital angular momentum which is represented by L, and it is given by -1 raised to power L. If we have, for example, L is equal to 2, then parity is minus raised to power 2. What will be the answer? -1 raised to power 1 raised to power 2, it will be +1. We have to see the sign, this plus, it means a system having L is equal to 2, we have even parity. If we have -1, L is equal to 3, we have -1 raised to power 3. So -1 raised to power 3 means -1, and it will give -1. So this is, we have odd parity. Negative sign here, we have odd parity. This is, we have even parity. Let's come on to the next page. Students, parity remains conserved during a nuclear transformation. For example, we have studied many laws. For example, law of conservation of mass, law of conservation of energy. Similarly, this is the law of conservation of parity in nuclear transformations. When there is a nuclear transformation, or you can say nuclear decay, their parity will remain conserved. इसका मीनिंग ये है कि अगर आपका न्यूक्लियस, फॉर एग्जांपल वी हैव डिस्कस दिस एन एग्जांपल, आई हैव रिप्रेजेंटेड दिस न्यूक्लियस, दिस इज एन न्यूक्लियस इन एन एक्साइटेड स्टेट. ये एक न्यूक्लियस है जो एक्साइटेड स्टेट में है. ये अपनी नॉर्मल स्टेट में, ग्राउंड स्टेट में आएगा. सो व्हेन इट विल कम टू ग्राउंड स्टेट, इट विल एमिट गामा रेज. तो इसने गामा रेज को एमिट किया. बट दिस डिके इज पॉसिबल only if the parity of this parity of the nucleus before decay is equal to parity of nucleus after decay. parity of these constituents, टोटल. एक न्यूक्लियस की चेंज हो सकती है, बट जो टोटल आपकी पैरिटी है, सिस्टम की पैरिटी बिफोर एंड आफ्टर द ट्रांसफॉर्मेशन वुड बी सेम. लेट्स ट्राई टू अंडरस्टैंड इट विद एन एग्जांपल. If we consider this nucleus, this excited nucleus to have even parity, and this is, we have nucleus in the ground state plus emitted gamma rays, okay, then this system of nucleus and gamma rays should also have even parity. This also have even parity. So even parity कैसे पॉसिबल है बच्चों? अगर न्यूक्लियस का पैरिटी इवन है तो गामा रेज का पैरिटी भी इवन रहेगा. सो दैट इवन इनटू इवन इट विल गिव इवन, ओके, प्लस इनटू प्लस इट विल गिव प्लस. और अगर दोनों ही नेगेटिव हैं, फॉर एग्जांपल इसका पैरिटी ओड है, तो इसकी पैरिटी भी, गामा रेज की पैरिटी ऑल्सो हैव, इट वुड ऑल्सो हैव ओड पैरिटी. सो दिस इज माइनस इनटू माइनस, इट विल गिव माइनस साइन हियर. सो आई होप यू अंडरस्टैंड. लेट्स डिस्कस थोड़ा सा और मैं इसके बारे में आपको बताऊं. तो अगर आपका पार्टिकल, देखिए, अगर आपके पार्टिकल की पैरिटी इवन है, तो जो आपके कॉन्स्टिट्यूएंट पार्टिकल्स हैं आफ्टर ट्रांसफॉर्मेशन, दे विल बोथ हैव ईदर इवन पैरिटी और बोथ विल हैव ओड पैरिटी. ये फिक्स रहेगा, या तो दोनों की ओड रहेगी या दोनों की इवन रहेगी. अगर आपके दो ही पार्टिकल हैं, तो दो से ज़्यादा हैं, देन डिस्कशन वी विल हैव टू फर्दर डिस्कस अबाउट दिस. बट अगर दो ही पार्टिकल हैं तो आपका ये सिनेरियो रहेगा, या तो दोनों की पैरिटी इवन है या दोनों की पैरिटी ओड है, अगर आपके पेरेंट न्यूक्लियस की पैरिटी इवन है. ओके, लेट्स कम ऑन टू नेक्स्ट पेज. इफ न्यूक्लियस चेंजेस पैरिटी, अगर आपके न्यूक्लियस की पैरिटी चेंज हो रही है, ठीक है, अगर मान लीजिए आपके न्यूक्लियस की, जो एक्साइटेड न्यूक्लियस है, उसकी पैरिटी ओड है, इनिशियली ओड है. आफ्टर ट्रांसफॉर्मेशन, जो ये आपका कंप्लीट सिस्टम है, न्यूक्लियस प्लस गामा रेज, इसकी पैरिटी भी क्या रहेगी? फिर ओड रहेगी. ओड के लिए क्या ज़रूरी है? अगर न्यूक्लियस की पैरिटी इवन है तो आपके गामा रेज की पैरिटी इवन रहेगी, तो ओड हो जाएगी. सो दैट फाइनल पैरिटी इज ओड, क्योंकि ओड ही होना ज़रूरी है, ठीक है. और यहाँ पे क्या है? न्यूक्लियस चेंजेस. न्यूक्लियस अगर पैरिटी चेंज करता है तो आपका जो पार्टिकल है, एमिटेड पार्टिकल या एमिटेड रेज, उनकी पैरिटी क्या है? ओड पैरिटी है, उनकी पैरिटी ओड है. अगर आपका पार्टिकल जिसकी पैरिटी इवन है, इनिशियली आपके न्यूक्लियस की जो पैरिटी है वो इवन है, और हमने क्या बोला है? दैट न्यूक्लियस चेंजेस द पैरिटी, न्यूक्लियस की पैरिटी चेंज होके ओड हो गई. तो अब आपके जो एमिटेड रेज है या एमिटेड पार्टिकल है, उसकी पैरिटी क्या होगा? वो भी ओड होना ज़रूरी है. सो दैट नेट कंबाइंड पैरिटी इज इवन. नेट कंबाइंड पैरिटी कितना होगा? इवन हो जाए. बिकॉज बिफोर ट्रांसफॉर्मेशन इवन, आफ्टर ट्रांसफॉर्मेशन इवन. बिफोर ट्रांसफॉर्मेशन ओड, आफ्टर ट्रांसफॉर्मेशन ओड. तो पैरिटी शुड रिमेन कंजर्व. बट देर इज a conclusion that if nucleus changes parity, अगर न्यूक्लियस की पैरिटी चेंज हो रही है तो जो आपका एमिटेड पार्टिकल है उसकी पैरिटी हमेशा ओड रहेगी. This is conclusion of this example, that if nucleus changes parity as a result of transition, then the emitted or absorbed particle have odd parity. So students, this is all about this lecture. We have discussed about statistical behavior and parity of the nucleus. So we will meet in the next class. Till then, thank you.